warahmatullahi wabarakatuh. So our next one, collisions. So our last subtopic actually. So collision, we have two types of collision. One we call it as elastic, one we call it as inelastic. Okay, elastic, inelastic. Sorry, it's not this one. Elastic and inelastic. However, for the case of inelastic, we have two types as well. We have just simply purely inelastic, or sorry, simply inelastic, and we have as well pure or perfect inelastic. So how do we differentiate those? Okay, so in the case of where it elastic, for sure confirm that it's gonna lose energy. So what sort of energy that being lost? We have kinetic energy loss. So whenever collision of a car and then the car just simply wreck, rosak, that is considered as kinetic energy loss. Okay, and in the case that when they still lost, yet after the collision they stick together, we call this as perfect, pure, inelastic. Okay. However, as you make comparison with elastic, this is a case whereby it has kinetic energy conserved and momentum conserved. Again, as we make comparison with elastic versus inelastic, inelastic still has momentum conserved. Momentum conserved. The two of them have the same conservation of momentum. The only difference is kinetic energy. One is lost, one is not. Okay, one is conserved and one is lost. And again, elastic collision, both momentum and as well kinetic energy conserved. However, in inelastic, momentum still to be conserved, but kinetic energy is not. Whereby perfect collision, perfect inelastic, again momentum conserved, yet they must stick together. Kinetic energy is not. Okay, and therefore their velocities are of the same value. Now, in the case of perfect inelastic, okay, you can notice in the expression, when we treat momentum conservation, we can factorize because they have the same V combined. Okay, let's go to the question. Alright, according to this example 6.4, and according to the figure, it shows that the final velocity has one single V as compared to original picture initially. Individually they have different V, but right after the collision they somehow stuck together, then entangle and having the same V final. Right, so this is a case where pure or perfectly inelastic collision. Now a pickup truck, so this is the truck, have a bigger mass which is 1800 traveling to the east, which with a velocity of positive 15 meter per second. Okay, east kanan lah. While another smaller car, compact car, which much smaller, in fact half of the mass of the truck, 900, traveling in the opposite direction, west. Opposite direction, arah kiri. So negative is to be considered. So later on, they collide head on. Head on maknanya depan, berdepanan berlanggar. And then later after the collision becomes entangle, melekat. So the question, find the speed of the entangled vehicles after the collision. So by right, since we are looking at perfect inelastic, okay, and definitely there is only one expression to be used, which conservation of momentum. So the way that we put conservation of momentum, very simple. They want the V final after it being entangled. So just put 1800, 900 of the mass individually, and as well initial momentum individually for the truck and initial momentum individually for the car, and just calculate. You are arriving with a value of 5 meter per second. Now next question. Now that you get that the V final becoming less, okay, of course, they want you to do a little bit of measurement in terms of change in the velocity of each vehicle. Each vehicles ni maksudnya for the truck is how much velocity changes, and for the car is how much. Okay, so final velocity each of the vehicles are 5 meter per second. So 5 minus 15. 5 minus 15. So notice that the answer is negative 10 and as well 20 meter per second. Okay, later on in our discussion, we're going to discuss how does the change of the velocity in terms of the analysis changes for individual vehicle. Right, so the next question is, they are going to verify that the system definitely going to lose kinetic energy. So that's the reason why the question is asking you calculate or find the change in the kinetic energy of the system. So when it says system here, it's trying to emphasize again that you have to measure kinetic energy for both vehicles. Okay. By right, what we did is, as you can see over here, kinetic energy individual of the vehicles initially, so for the truck, okay, half m v squared 15 plus for the car, half mass car, and then v in the opposite direction, okay, but it's not gonna show something because this is scalar. So kuasa 2, the negative would be just dissolve, okay. So arriving with a value of answer to the power of 5 joule, okay. And then after the collision, they are entangled. So of course you can do the factorization or even repeat the same expression as earlier on. Boleh repeat balik, tak ada masalah. Or you can make it simpler by factorization. So that's why you add on the masses and then times with half and also v squared 5. Yeah. So you are arriving to the power of 4 answer. So earlier on is to the power of 5 joules and now it's to the power of 4. Significant loss of kinetic energy. Since the question is asking what will be the change means pi delta. Delta means final tolak initial. So kinetic energy final tolak initial maknanya 3.38 to the power of 4 minus 3.04 to the power of 5. You are arriving with a negative product. Negative product means loss. Loss. Okay, negative ni maksudnya dia loss kinetic energy. So where does this loss kinetic energy goes to? Now, according to the descriptions over here, it loses almost 90% of its kinetic energy. How do you get this value of 90%? Very easy. The change of the kinetic energy divide with total kinetic energy initially, which means negative 2.7 to the power of 5. Now, divide it with 3.04 times 10 to the power of 5. And then times 100%. So you're going to get something approximates to 90%. So 90% is huge, big number. Almost all of the kinetic energy lost. Okay, where does this kinetic energy goes to? It goes to getting injury, one, or even wrecking the car. Maknanya rosakkan kereta. So, or even making sounds, or even fire involved or sparks involved. So those energy are now being converted in other forms. Okay. And you will have noticed as well that the smaller car, okay, the bigger the car, the more massive the car, the bigger the size, the bigger mass size of the car, it will undergo a smaller change of the velocity because of the size, because of the mass. Okay. So negative 10 as compared for the truck. Truck is having negative 10 change of the velocity, quite small, as compared with the car, bigger value. So the car have experiencing differences in the velocity quite significant as compared to when it's larger in mass. Right, so you can see over here, this example is involving when two objects touch, contact, collides with one another, and how does the approach of the equation momentum conservation is being employed as compared to the previous example whereby an archer originally being alone and then get separated. So the keywords over here is you have to identify mass and its associates. Apa yang dia punya corresponding V and U dia. That's the trick to this question.